Hello guys, I'm Malk Khalid. In this video we are going to discuss the chapter 38 in Halliday section 2, which talk about the photon and quantum of light. Before starting, we have three main definitions, so let's begin immediately. We have main three definitions. Let's begin with the quantum physics. The quantum physics, which is also known as quantum mechanics and quantum theory, is largely the study of the microscopic world. In other words, it describes the physical properties of nature on an atomic scale. Okay, now let's move into the another one, which is quantized. In that world, many quantities are found only in certain minimum elementaries or amounts. These quantities are then said to be quantized because it's consisting of many smaller parts than it. Okay, now let's move to the third one, the quantum. The quantum means the smallest possible discrete unit of any physical property, such as energy or matter. The plural of this world is quanta. Here's an example to make it easy. The USA currency is quantized because the coin of least value is the penny, or $0.01. This is very small amount actually. And the values of all other coins and bills are restricted to integer multipliers of that least amount, which means the currency quantum is $0.01 and all great amounts of currency are of the form of n multiplied $0.01, where n is always a positive integer. Now, let's begin our story. In 1905, Einstein proposed that electromagnetic radiation, or simply the light, is quantized and exists in elementary amounts, which we call quanta, that we now call it photons. If this seems normal to you, no it isn't. Einstein's proposal means that the light is made of particles, like anything else. But the classical physicists believed that the light is a wave, which means it's consisting of a combination of electric and magnetic fields, which has frequency and wavelength and speed, as we know. So, was Einstein right? Actually, yes, and he took Nobel Prize for that. The mystery here that the classical physicists weren't wrong. I know this seems confusing, but they discovered that light can be wave or group of photons. How, why, when, anything, these questions can be discussed later, but let's keep it simple this time. Now, according to Einstein's proposal, photon has energy. Yes, this is weird, but we're going to discuss this in the next video, ISA. Another question, how can we calculate the photon's energy if we suppose that has energy? Yes, this is a good question. Here we have nice equation which can tell us how to calculate the photon energy. It says the E equal H times F. E refers to the energy of the photon. H refers to the Planck's constant. H equal 6.63 times 10 power negative 34. The unit, don't forget it, it's joule multiply second. The F is referred to the frequency of the light. But please, focus. This is the energy of the single photon. The total energy of the light is Fh times any integer, like in the USA currency example, if you remember it. Moving to the last point today, we have two main events, observation event and emission event. Let's begin with the observation event. Here, when the light hit an object, the photon energy transferred to the atom of this object, and the photon will vanish or disappear, in another word. Okay, here the photon energy absorbed by the atom, like in the sunglasses, for example. Moving to the second one, emission event. Here is the totally opposite of the observation event. The object's atom transfer their energy to the light, and the photon will appear. Here the object emitted its energy to the photon, like in the lamp, for example. I hope you like this video, guys. If you do, please like and subscribe our channel, and you can share it to who needs it. Please tell us your opinion in the comments. Thank you for watching. Bye bye.